as I think we're all aware, at least the three of us here, additive manufacturing is really cool. But I think with all that coolness and novelty comes a lot of hype. And I think a fair bit of misconception to come along with that. So what are these common misconceptions that you really see surrounding this field of additive manufacturing? And how do you try to debunk them?
One of the biggest misconceptions that we work with on an almost daily basis is a lot of people think that additive, especially from a laser perspective, is a plug and play. You plug in your machine, you dump in some powder, you press a button, and it prints magically and perfect parts every single time.
I wish.
Right. I hate to break it to you out there, but it is not the case. Yeah, we spend a lot of time just explaining all of the little nuances that go into what it takes to print additive components for our customers. There's a lot that goes into it. There's a lot that you need to know about how to set up the machine, how to calibrate the machine, how to prepare a CAD file. So you can print a lot of things and you can print almost anything, but there are still a couple of rules and guidelines that you need to follow to print a successful part. We talk a lot about that as well. And then once you actually get to the printer, get that good CAD file loaded, making sure that machine is running properly and giving you the material properties that you want is also kind of a challenge. These machines can be a little finicky at times, so we are constantly making sure that they are printing good part and printing good material. So yeah, there's just a lot more that goes into it than plug in a machine and press play.
So based off that, since there's so many things that go into it from the design standpoint and the machine parameter standpoint, what have you found to be the most challenging part of the entire process, or maybe the most time-consuming part of that process?
Honestly, I think a lot of the material development and parameter development takes a lot longer than people might expect. So yeah, you can spend a long time developing parameters to get a specific density or mechanical property requirement that you're going for. It can take a while. And so I think that's where a lot of the time and the money is spent is developing those materials. The OEM, the machine manufacturers such as GE Additive, some of your other big manufacturers as well, that's really what you're buying when you're buying that machine, and that parameter set is all of that experience that went into it. We pride ourselves on, delivering some great parameters along with that, but then knowing how to use those parameters, knowing what they're good for, having the part then being able to print with that parameter is also a big portion that goes into it.
But hopefully, like over time, you'd be able to find similar parameter sets, right? Like you could develop, if it's a similar part, you could add a similar parameter set for the respective machine.
Yeah, absolutely. Usually we develop parameter sets by material. So we might have a couple of different parameter sets for a given single material that might be focused more on productivity or more focused on getting really good mechanical properties or really good surface finish. But within a specific material, as we gain more experience both with that material on that machine and then similar materials across multiple machines, we've built up kind of a wealth of knowledge that we're trying to reduce that development cycle time up front.
So on the other hand, what would you say are the primary benefits that you see with the increasing adoption of additive manufacturing compared to what we've seen in the past with traditional manufacturing?
Yeah, there's a lot of really good benefits for additive. The first and foremost, which I think might be the most obvious, is complexity, part complexity. So you can print, like I said, not necessarily anything, but you can print a lot of different things with additive. There's a lot of design space that's been opened up with, laser powder bed fusion, with binder jet, with electron beam melting. There's just a huge design space that's opened up to, be able to find new applications. But in some cases, it is also a savings on time and cost. So especially when you start talking about castings and investment castings, there's a lot of cost that goes into, and time that goes into making the tooling required for that process. So with additive, you don't need that tooling. You can just print the part and get basically an equivalent part out of it without having to go through that whole cost and time cycle.
So not only speaking to reducing cycle time and developing some of these complex manufacturing processes and complexity, but also how does additive play a part in simplifying supply chains for projects that are immensely complex. We're pulling in parts from many different suppliers in many different corners of the industry.
Yeah, so another great thing that you can do with additive is you can start combining parts together. So a lot of these little parts with high complexity that you might need to source independently or build separately and then join together, you can now print them all as one part. So that reduces, like you said, supply chain, or reduces the time to create POs and source these parts. So yeah, there's a lot of benefit to taking a lot of parts in an assembly and combining them into one, now that you have that design freedom to print that complex geometry.